This is Lesson 5-8 Scale Factor. The objective of this lesson is to learn to make comparisons between and find dimensions of scale drawings, models, and actual objects. Now, a scale drawing. It is a two-dimensional drawing that is proportional to the object. And a scale gives the ratio of the dimensions in the drawing to the dimensions of the object. For all dimensions are reduced or enlarged using the same scale. Now, how do we read this? When you see this, it says scale A:B. It's read A to B. For example, the scale 1 centimeter, 4 meters is read 1 centimeter to 4 meters. Okay, so to read a scale factor like 1:20, these are all different ways that we can write a scale. That's 1 unit on the drawing is 20 units. Or for 1 centimeter, 1 meter, it's 1 centimeter on the drawing is 1 meter. And 1/4 inch equals 1 foot. Can be said 1/4 inch on the drawing is 1 foot. So looking at how we can use this, we're going to look at our first example here. The length of an object on a scale drawing is 2 centimeters, and its actual length is 8 meters. What is the scale? Well, when we're talking scale, we want to find out what it is when it's just 1 centimeter over how many meters? Well, let's keep our labels the same, and we put 2 centimeters at top, and we put 8 meters on the bottom. That way we keep our labels the same. Centimeters are on top, meters are on bottom. It's important to make sure you keep them the same, or else you're going to end up with the wrong answer. Now what we're going to do, if you go back and remember this, is we cross multiply. So you're going to take your 2 times your x and get 2x. And then you're going to take 1 times your 8, and you're going to get 8. And then you're just going to solve, and x equals 4. But you're not done there. Make sure when you're writing this that you're writing it as the scale. So the scale is going to be 1 centimeter to 4 meters. So looking at number 2, the length of an object on a scale is 4 centimeters and its actual length is 12 meters. What is the scale? So remember, we're going to set it up as a ratio. You're going to make sure you put the scale on top and the actual on the bottom. So we're going to put 4 on top, because that's our scale, 12 on the bottom. We want it to be 1 centimeter to something, so it'll be x meters. So again, go ahead, cross multiply, find out what x is, and write your scale factor. Pause the video so that you can do this. If you did your work correctly, you should have gotten 1 centimeter to 3 meters. So let's look at number 3 as our example. On a map, the distance between a waterfall and buried treasure chest is about 4.5 inches. The scale of the map is 1/2 inch to 10 feet. What is the actual distance between the waterfall and the treasure chest? Remember, we're putting scale on the top, actual on the bottom. So our scale on top, we've got our scale is going to be 1/2 inch. I'm going to write that as a decimal though. I'm going to put 0.5 inches over 10 feet. So that means this fraction is going to have inches on the top, feet on the bottom. So let's look. What is our scale? Our scale says that it's about 4.5 inches. So 4.5 inches. but we don't know our actual. That's what we're trying to find. So now that you have those, we're just going to cross multiply. So 10 times 4.5 is going to give us 45. And 0.5 times x is going to give us 0.5x. Divide by our 0.5. And you're going to get that x equals 90 feet. So our answer is just going to simply be 90 feet. Make sure we label. Let's try another one. Number 4 here. On a map, the distance between a picnic area and the horseshoe pits is about 6 inches. The scale of the map is a 1/2 inch to 12 feet. So again, let's put our 1/2 inch to 12 feet. And that's going to equal, again, remember, inches on top, feet on the bottom. Got to stay with the same. Okay, we know that it's 6 inches, so we're going to put 6 inches at the top, and our x is what we need to find. So again, the first step is to cross multiply. So you're going to get 12 times 6 is 72, and 0.5x. Divide by your 0.5. Those cross out, and you get that x is equal to 140. Don't forget, we've got to write it as put our label on everything. So it's going to be 144 feet, because that's where our x was with the feet. 144 feet. So why don't you pause the video and try number 5 on your own. If you did everything correctly, you should have gotten 75.6 feet. Make sure you have your label on there. Now a scale model. A scale model is a three-dimensional model that accurately represents a solid object. The scale model is mathematically similar to the solid object. Similar means it's the same shape, but it's just a little bit different size. That's what similar is. So let's try one of these. A model is 27 feet tall, and the house was made using a scale of 2 inches to 3 feet. Remember, we put scale on the top, actual on the bottom. So we're going to have 2 inches on top, 3 feet on the bottom, and that's going to equal, remember we got inches and feet. But pay attention, 27 is going to be the actual, right? That's the feet. So we make sure we put the 27 down here, and then our unknown is the model size. But just because the x is on top doesn't mean anything different. You're going to solve it exactly the same. You're going to cross multiply. 3 times x is going to give us 3x. 2 times 27 gives us 54. Divide by 3 to get our x alone, and x will equal 18. So your answer is going to be 18, remember, inches. So that's going to be your answer. Now number 7 is going to be just like this, so make sure you pay attention to putting the scale and the actual, scale on top, actual on the bottom. Remember? When you get done with this, bring it up to me and have it checked.